So here's a question from Mastering that has to do with um, a reaction with cyanide poisoning. And what we're doing is we're given the concentration of iron in the blood, a volume of blood, and then we're given an amount of cyanide. And we want to know how much iron from what we started with is now in this toxic complex. So let's work this in a series of steps first. So first let's figure out, so this is mostly a stoichiometry kind of problem, but what we're going to have here is we're starting with 1.3 times 10 to the minus 5 moles of iron 2 per liter. And we know that the human has 5.7 liters of blood. So in a person, or this person, we have 1.3 10 to the minus 5 times 5.7. So we have 7.41 moles of iron. Oh, I didn't put it's times 10 to the minus 5. Sorry. I was like, that's a lot. No. Small concentration. Okay, so that's how much moles. So this is how much we're starting out with. Now let's figure out how much cyanide we're adding. Now this is a completely soluble solution because sodiums are always soluble. So here we have 17 millimolar, and we're dividing that, let's see, so that's here that's gonna be millimoles per liter. So I'm gonna go ahead and say this is 1,000 milliliters. Maybe that's okay. So millimolar would be this many millimoles per liter, and I'm just making the conversion that a liter is 1,000 milliliters. And we have 10 milliliters. So let's do that. 17, I can't see what I did, times 10, and let's divide by 1,000. Oh, that's how many millimoles. I need to go to moles, sorry. And we know that there are 1,000 millimoles in 1 mole. We need to get 2. It'd probably be easier to do this whole thing in millimoles, but that's okay. So now we need to divide by 1,000 again. I was like, that's too big. There we go. 1.7 times 10 to the minus 4. Now, let's look at our ratio up here. And we know that it takes 6 moles of cyanide to bind with 1 mole of iron. So we're going to use a mole ratio here. All right, so this is moles of cyanide. So we know here, I'm going to kind of continue on here. So that's how many moles we have. And then we know from our stoichiometry equation. So see, stoichiometry just doesn't go away. 6 moles of cyanide require 1 mole of iron 2. So it's going to tell us how much iron 2 is used. All right, so let's just take that and let's divide by 6. So 2.83 times 10 to the minus 5 moles of iron are used up. Because that's what it wants. It wants to know how much blood is sequestered. That means occupied, which would be this. This is how many moles of iron are occupied with cyanide. So from here, it's actually quite simple. We just need to do a percent. So we take what we're stuck with, divide by 7.41 times 10 to the minus 5, because this is moles of iron and moles of iron. So those cancel out. And times 100. (10 to the minus 5) and times 100. All right, so this tiny amount of really dilute solution occupies over a third of the iron available in your body. So that's why cyanide's toxic.